Good morning everyone. Myself Shailaja NS, Assistant Professor, Computer Science and Engineering Department, Government Engineering College, Musle Vasalli. In the previous session, we have discussed about the different test cases. Then continuation of that, today also will discussing the different test cases. In the different test cases, we have followed some of the guidelines that has to be executed one after the another in sequence. The first is in test the software with a sequence which is having the only a single value. We have to group to all the set of objects, then which is having the single value, those test has to be verified first. Then for the use the different sequences in the different test cases. For these set of test cases, we have to identify the test cases within the three different levels. It has been categorized into first level, middle level and the last level. It has to be go in sequence, one after the another. Then the test cases has to be identified with the sequence of a 0 length. Then we have to follow some of the general guidelines for the testing. We have to choose the set of inputs, then force the system to generate. After getting the system has to be tested, we will obtain a set of error message. Then design the inputs. It has to cause the buffers overflow. Whenever the buffer becomes overflow, you are supposed to repeat the same set of inputs for the same series of inputs for a numerous times. It has to be executed for a numerous time until the buffer does not cause an overflow. Then it has to force for the invalid outputs to be generated while conducting the test cases. Then we have the test has to be identify the test cases to be always in the average level. It cannot be either be too much low or it cannot be too small. Then we have to conduct the path testing. Path testing is also known as an white box testing. White box testing can be the white box testing mainly used for the internal structure of a design and coding of a software. Then that has to be tested to verify for the good software to flow of input output and to improve the design and as well as the usability for providing the good security. In white box testing, the coding is visible to a testers. It's also, if it is visible to the testers, it can also be called with some other names. Those some other names can be either it can be called as a clear box testing, or it can be a open box testing, or can be a transparent box testing, or it is a code based testing, or it can be a glass box testing. All is relevant to the mainly depends on the flow of the internal structure for the input and as well as a output. Whereas in the it has to be represented in the graphical notation. In the graphical notation, it has to be executed in the flow. Okay, as usual in the flow chart, each has to be either we have arrows and as well as circles, or it can be the rectangle, or it can be any predicates, right? Each has to be identified their name. For example, arrows, as usual, it can be known as it can be called as edges. Edges it shows the flow of control, how it is flow from one step to the next step. Then in the next is you have called as circles. Circles is also known as nodes. Okay, each circle it has to be represented as one or more actions. Then it has to be rectangles. Rectangles has to be areas. It is bounded by edges and as well as nodes, and that is altogether it can be called as a regions. Then a predicate node is a node containing a condition. Then it is identified by the different set of the flow diagrams. The first it has to be represented. There are two circles. In between two circles we have a one arrow. It is passing from the first circle to the second circle. It has to be identified with the system has to be tested in a sequence. The system has to be tested in sequence. Next we have the four circles. Four circles are interacting with one with the another, interacting with each other. Then that is represented known as a if condition. Then for example, in the looping, the same set of input has to be repeated until it has to satisfy the condition, where it has to flows in the with the three different level. First level has been executed. Then it has to, if it is for example, it is initially set to a for 5 inputs. Then if it is executed after 1, then it has to repeat it once again. It has to repeat until it all the 5 inputs are executed. Then the same thing in the next it has to until has to be executed. We have 3 circles. In the 3 circles, one circle has to be the control has been transferred to the second circle. Then after it has to repeat it until the condition is satisfied. Then it has to move to the previous step. Then keep on, it will move to the next step in sequence. Then the last one is a case. Just like in the switch statement, we have n number of cases has to be executed. For each cases has to be executed with the different series of the case values. For example, case 1, case 2, case 3 and so on up to case n has to be executed. After the case n has to be executed, then it has to move in the next sequence. Then in this diagram, just we are representing how the example has been indicated from the start. Then we have condition has to be with the condition has to be executed. Then the next set of statement has to be executed. Then moves to the next condition. If it is true or false, if it is true, then it moves to the left side. If it is false, moves to the right side. Then again in the left side we have again it has to check for one more condition, if it is true or false. If it is true, it has to execute the next set of statement. If it is false, the next set of statement has to be executed. Then try to combine this along with the false condition. It has a set of condition has to be executed one after the another. Then finally it has identify. Then it has to repeat for n number of times. Whether if it is becomes a false, then only it is comes out of the loop. That is represented with the flow diagram. Then this is one of the example. For the previous example, we are the complexity is known as an cyclomatic complexity. Cyclomatic complexity, it has to check. Cyclomatic complexity is a software matrix that is used to indicate the complexity of a program. It has to identify what is the complexity of the program is known as a cyclomatic complexity. It's a quantitative measure of the number of linearly independent paths. It is a quantitative measure of a number of linearly independent paths that has to pass through a programmer source code. That can be identified with the following diagram. It in the last previous example, just now we discussed the field. If it has to execute it after reading, then it has to go through the if condition. If it becomes true, then it has to add field 1 to a total. Then it has to increment the counter. Else it has to go for the, if it is false, then it is moved to the second field. Then it has to check for the true or false. If it is true, then print the total. Then along with the total, we need to have identify the counter. Then if the counter has started, we are supposed to reset the counter. Otherwise, else if it becomes false, subtract field 2 from total. Then afterwards, if you get it total, then it has to be comes out of the loop. Then finally we have to print the end record. Then end the loop, and for the print the finally what is the counter. In this cyclomatic complexity, we have different set of paths. Okay, for example, we can have the path. It can be given with there are 4 different types of path. It can be indicated with one has to be directly connected with the 9, the number 9. Then the second path has to be follows from, the control will flows from 1 comma, it has to move to the second node, then it has to move for a third node, then it has to follow with the node 8. If it has to repeat, that's why once again it has moved back to the step 1. Then if it is becomes true, then comes out of the loop, it has to proceed to the final destination 9. In the another alternative steps, we have same thing. In the right, if the condition become false, it has to be executed. It has move for 1 to 2, then 2 to 4, 4 to 5, 5 to 7, 7 to 8. Then it is check whether it is true or false. Then if it is still it is true, then it has to repeat until the condition becomes exit, right? Then it has to go to the step 1. Then finally it goes to the last node 9. Then the last path, it is given as it is moved from node 1 to node 2, then moves to the node 4 along with the 6, then 7, 8. Once again it has to repeat. It moved to the step 1. Then finally it is comes out of the step with a 9. Within this cyclomatic complexity of 4, we have the 4 different paths. Within the cyclomatic complexity of 4, computed using any of these 3. You can use any of these 3. It is given as the number of edges, the number of nodes, and plus the number of terminal vertices. Okay, it is given with normally it is of the set of values, it has 2 values. For example, 1 comma 9. Then it has the second one, either you can have only the predicate nodes plus a 1. We have a predicate, that is 2 values, either the predicates node plus a 1. The number of, it can be given with the number of regions of a flow graphs. In the cyclomatic complexity, it provides a upper bound for number of tests. Then we will move on to the next test is known as in component testing. Which are all the components in the software testing? We have the set of the components, or also known as a composite components, that have a several interacting objects. It can be of a different set of the objects. Each functionality of the component, it can be accessed through a different set of interfaces. We have the interfaces, it can be somewhere whenever if you want, if in the program we can have different interfaces, has to be called many number of times whenever it needs. That's why we mainly focus on those component interfaces that behaves according to its specification. For example, in the unit test on the individual objects within the components have been completed. That can be represented in the interfacing diagram. We have it in the interfacing testing. The test cases has been divided into different modules, each with the separate blocks. For example, we have the 2 objects that can be A and B. A and B has to be tested with, we have to shown with the interaction with each other, that has to be interact with each other, then finally come across with the A and as well as a B. The combination of those together, that will be put into the object C or the node C. That is how it has to be represented, how that can be executed. Then combination of those 2 inputs and integrated with the C. Then these objectives are we have identified with the it has the fault has any, if your test cases has to be executed, we are come across with the many faults. The objectives are detect faults due to interface error. We have a set of interfaces that can be specified in the program or in the cyclomatic test. We have different interfaces. In the for this example, we are trying to come across with the 4 different set of interfaces.